from the Azure SQL Product Team here at Microsoft, and today we'll be covering a few different topics related to Azure SQL. If you have any questions, feel free to post them on the chat. Also follow us on our social handles listed at the bottom of the slide, hashtag Azure SQL at Azure SQL, so you can keep up with different news from us directly and a way to engage with us also. So with that, the topic for today's session is what are the recent updates in the product, as well as there are many different deployment choices in the cloud for Azure SQL. We will talk about what to use when. Mohamed, you want to advance the slide? Okay. So this is the high-level agenda we'll cover. We'll cover the various offerings that are available in Azure SQL when you're looking to migrate to the cloud. How do you pick different destinations? And then we will share recent updates as well as some demos of some of the new features. And finally, cover how do you get to Azure through various migration tools. So when we talk about Azure SQL in the cloud, it's basically a family of different services. And there are two main ways to look at it. The first one on the left is infrastructure as a service, which is basically your full-blown SQL server running on Azure virtual machines. And this is ideal for scenarios where you want to lift and shift existing workloads that you already may have on premises or hosted data centers, and you have full control of the environment. The second one is the platform as a service offerings. Here you have two choices, whether you want a single database or a full instance. If you want a single database, you can pick the Azure SQL database offering. And here you have multiple choices between general purpose, business critical, hyperscale, as well as provisioned versus serverless compute. And we will talk about some of these characteristics shortly. However, if you are migrating existing SQL Server workload and you need all the instance level features, you can pick Azure SQL Managed Instance. The main difference between the two is one is an instance level offering, the other one is a database level offering. However, the platform itself is common for both, meaning they're built on the same code base running on the same Azure Service Fabric, which means you get all the built-in capabilities such as high availability, automatic backups, automatic patching and service updates, running the latest and greatest version of SQL Server engine at all times, yet giving you fully backward compatibility all the way back to SQL Server 2008. Now let's dive deeper into some of these offerings. So one of the things when you are looking at Azure SQL is you can use it for multiple workloads, just like you are on premises. It can be operational transactions or reporting workloads. You can migrate existing apps and maintain compatibility. Native cloud apps with SQL as your data layer. It is designed for the future. With the hyperscale offering, you don't have to worry about your compute or storage scale. You can start with a very small compute layer or a small storage layer and then scale up. Today we support up to 4 replicas for the compute as well as up to 100 terabytes of storage. So it really helps you future-proof your investments, and you only pay for the size you start with. And from a price performance perspective, if you're looking to optimize your workloads and if you have intermittent workloads, then serverless really helps you there, where you only pay for literally what you use with very granular billing model, which we'll look at later. And you can switch between a provisioned compute and a serverless compute depending on your workload characteristics. And finally, you get the best TCO with SQL runs best on Azure. There are several benefits such as Azure Hybrid benefit, where your license is completely waived. You only pay for the compute and storage. And you can also use reserved instance on top of this to get additional savings compared to other cloud providers. So whatever deployment choices you pick, some of the core platform capabilities such as built-in AI, which enables intelligent database and automatic tuning, lets you further optimize your workloads and hence further save costs. We have industry-leading security features with end-to-end security, whether it's data at rest with transparent data encryption or always encrypted, whether it is data in motion encryption with TLS or data in use encryption, again with all encryption, always encrypted, either with service managed keys or customer managed keys. You get the latest and greatest security features, which also speaks to the least vulnerabilities in the industry compared to any database vendor in the market. And HA comes built in. Depending on the tier you choose, you can have up to 4 nines and a 5 SLA, which is the first and the most advanced SLA in the industry, and with no additional cost. For example, if you pick business critical tier, every primary replica automatically creates 3 additional secondary replicas, which gives you that SLA guarantees. Now moving ahead, let's look at some of the benefits. So we recently did, one of the analysts, GigaOM, published this benchmark where they compared the price performance for running the same workload, PPCE-like workload, RDS, and they also ran SQL Server on VMs and on EC2. So running the same workloads, you can clearly see that in both cases, the blue bar represents Azure, where customers can realize significant savings and get the same performance. And with Azure hybrid benefits and reserved capacity, you can get up to 80 to 86% savings, whether you choose IaaS or PaaS. The full details of all the tests that were done and comprehensive report is available at the link at the bottom of the slide. Now let's switch to when to use what. You briefly heard about different offerings. So now how do you pick different deployment choices? So here there are a few different questions you need to ask before you decide what target is right for your application. So here we can, these questions are common, whether you're migrating existing apps, whether you're migrating the apps and modernizing new features, or you're building new features. The two most common questions you need to answer is what level of control you want, and then second, what capabilities are you looking to build in your application. If you want a fully managed environment where you want to control everything, and you want all everything from OS level access to specific version of SQL Server, and you want to control the downtime for patching and upgrades, and you want to co-host the application, then the best target for these applications will be SQL Server on Azure VMs. If you want a fully managed environments where you don't want to burden of operating the environment, such as upgrades or updates, HADR, backups, security, etc., then you pick the managed instance if you want instance level features such as link servers or application or CLR or SQL agent. However, if you want just a database, but a fully managed database as a service model, let's say you're a multi-tenant application where you have just a single database model for each customer, then database as a service is the right target. The main difference is at that scope from a programming layer, but the platform level such as HADR, backups, updates and upgrades are all common, whether you pick the instance model or the database model. And now let's look into the characteristics of each of this, which Mohamed will cover.
Thanks, Ajay. Can everyone hear me okay?
Yep.
Cool. So as you know, Ajay covered the basics of how do you differentiate between using the right flavor of Azure SQL, given the options that we have. Now, one of the things that Azure SQL really stands out is with the developer community, we have made it possible for you to integrate your applications with Azure SQL using a multitude of options, whether it's programming language like C# or Java, or Node, PHP, Python, Ruby, and Go, we have covered all grounds to make sure that you get the integration points that you need to build your modern applications in the cloud. So if you look at all the offerings that we have in Azure SQL, you can run them on Mac OS, Linux, and Windows today. So that gives you that flexibility to run multi-platform SQL offerings. Now, as I said, what we've made sure is when we delivered Azure SQL as a products or family, we made sure that all your modern applications are supported to the point that you don't necessarily have to worry about another platform to do things like your JSON support or change tracking from a developer perspective, or if you want to extend your SQL offerings to beyond relational using graph databases for things like social media applications, or if you want to make your apps more location aware using spatial databases, we made it possible using the same Azure SQL offerings. And not to discount that Azure SQL also supports your analytical workloads, or as we call hybrid analytical workloads today, with column store and in-memory tables and models that we can support in Azure SQL. Plus, with the benefits of advanced security and all the security options that we provide with SQL Server and Azure SQL, you get all the goodness of things like always encrypted with your applications, data masking, row-level security, encryption at rest using TD, and all the security features that come bundled as part of it. So this holistically gives you a product that supports not just your databases, but also that high level of integration with your applications, with security built in and everything thought through. Now, as you've seen in the previous slides, we distinguish our offerings on Azure SQL in 3 different categories, which is IaaS, which is SQL on VMs, to PaaS, ranging from managed instance to single databases. We will, to a large portion of this talk, we will skip the IaaS section, given that's an area where most of us are very comfortable with. We'll focus our discussions around PaaS services. Now, when you think of Azure SQL PaaS, the 2 broad categories are managed instance and single databases. As Ajay mentioned, if you need the goodness of instance level SQL offering with things like link servers, you want to run your SQL agent jobs, etc., managed instance is the best platform of choice. And managed instance has become the go-to platform of choice for migrating your on-premise SQL server. Primarily because it gives you the full surface area of SQL Server on the cloud, and it also gives you the added benefits of Azure Platform as a Service, along with reduced cost with hybrid benefits. Now, one of the uniqueness of managed instance is that when we provide managed instance to our customers, we just don't provide it as a service, but rather we take care of things like isolating it from multi-tenants and other customers. You essentially get a dedicated tenant of managed instances where we deploy SQL instances in a virtual cluster. And those clusters are isolated both from a network perspective and tenancy perspective. So you'll never have the concept of noisy neighbors trying to impact your workloads, or someone trying to come into your network through malicious modes and whatnot. So we've taken care that we've designed managed instance to support both levels of isolations and make sure that you can bring in your Active Directory from on-premises to managed instances using integration with Azure Active Directory. So today we support AD identities using Azure AD through password hash and pass-through authentication. So seamlessly, you should have a database service that works as if it's your SQL Server on premises, but it's on the cloud. Now, if you switch gears to the single database mode, Azure SQL Database in a single mode is simply a database offering where we provide a database to our customers to run cloud-native applications, to run workloads without really having to consider instance-level configuration or without worrying about instance-level capabilities. So with that in mind, we have single databases that primarily meet your needs of applications that just need a single database. But over time, we've seen tremendous growth in volumes of data that we consume from applications across industries, where just having a database is not sufficient if you're not able to support hundreds of terabytes of data sets. So Hyperscale is our new offering where we allow customers to use single databases and allow them to automatically adapt their workloads and scale up to support to 100 terabytes database. And the scale up happens automatically as your workload increases. And at the later part of this session, I'll show you a demo where you can see how automatically the service on Hyperscale database had scaled up depending on the ingestion of data that's coming in from a very small number of data sets to growing needs. Plus, with Hyperscale, you also have the concept of scaling out to read replicas without impacting your primary compute. Now, the way we've been able to deliver this architecture is by literally ripping apart SQL as a service and providing multiple layers of resiliency and redundancy. So if you look at Hyperscale as an architecture, we primarily have broken this down into 4 different components. You've got compute, you've got page servers, you've got data storage, and you've got log. Now, typically in a SQL environment on premises, all of this would sit in a single machine. What we've done with Hyperscale is essentially in your compute layer, we provide you with a single primary compute and multiple secondary replicas so that your read queries can be directed towards read replicas without having to impact your primary compute. Now, then you have the next layer down, which is your log service. Now, log service in itself has been delivered as a service where any transactions that come in are necessarily just hardened at the log level without having to worry about the layers below. So once the transaction hits the log service then takes responsibility to push those transactions down to your page servers and also replicate the same to secondary storage. So this is where it gets interesting, where now we support page servers to scale hundreds of page servers depending on your workload. We start small with a 128 gig page server, and it keeps on adding page servers as your workload increases. Now, all of these page servers have local caches on them to cover your data set completely on those page servers. So as long as you have workloads that are coming in to both read and write, log service should be able to take care of that communication and also get you back the data from the page servers. Now, the only point at which the architecture interacts with the remote data storage is when the database needs to do checkpoints or take snapshots of data in a remote storage layer. So that becomes a permanent storage layer, right? Now, with that, you would also realize that you can rapidly scale up your platform without having to worry about the size of your database, because the scale up would happen essentially in your compute nodes in the first layer, while your data sets are increasing at the page server and the remote storage layer. This also gives us the option to restore databases quite quickly, where we've proven that database restores, regardless of the size of the database, would happen in minutes and not hours or days. One of the biggest use cases that we are seeing for Hyperscale is for real-time analytics and HTAP workloads, where you require the power of analytics and aggregated queries without necessarily having to use an MPP system like an Azure SQL database or an Azure SQL data warehouse, or what we call Azure Synapse today. So if you don't need the power of MPP, if you just need data marts running on SMP architecture, you need to just do high levels of aggregation and real-time analytics, Hyperscale has become the go-to choice for those kind of workloads. Not to discount, Hyperscale is a single SQL database offering, which also supports OLTP. So I quickly wanted to jump into a demo to just demonstrate the capabilities of Hyperscale. For the purpose of this demo, what we've picked as a scenario is IoT devices transmitting data for consumption on an Azure SQL database hyperscale. Now, you could consider in this particular scenario as an IoT set of devices coming from either connected cars platform or supply chain in retail from refrigeration systems. You could just fictitiously imagine a bunch of IoT devices transmitting data. So in this particular demo, I've created 5 different IoT based containers, which will constantly emit data at the rate of about 10,000 messages per second. That gets ingested into event hubs through to Stream Analytics. Now, Stream Analytics is a service that does basic transformation of data before you can structure it and push it into database systems. So Stream Analytics basically gets the data from these IoT devices coming through event hubs. It transforms it to a structure that can be ingested by SQL database hyperscale. And for the purpose of this demo, I've got a primary node in Hyperscale and one read-only secondary copy. So with that, I'll quickly switch my desktop so I can show you the demo. All right. So what I've got here, can everyone see my screen?
Yeah.
Okay. So what I've got here is a real-time dashboard that monitors this whole scenario. Just to re-explain that, I've got 5 different data generators here, as you can see from the colors on this graph. Each data generator is running in a container on Azure that's emitting data constantly through to event hubs. Event hubs then pushes that to Stream Analytics, where Stream Analytics gets these input events and pushes out the output events to Azure SQL Database Hyperscale. Now, you can see from this graph here that Azure SQL Database Hyperscale is fairly active. You can see the CPU percentage, the data IO, and the log usage, right? Now, what I also want to show you is within the Hyperscale database, I've got one primary compute, which is running a 16-core machine, and I've got one secondary replica. So as part of this demo, I've got a bunch of queries that I want to run. So this is Azure Data Studio. For those who don't know, Azure Data Studio, it's become a multi-platform client tool to connect to Azure SQL Database, where you can have a bunch of connections and run queries either natively using SQL queries that you're used to, or you can run notebook-style queries using multiple languages like SQL, Python, R, etc. So for the purpose of this demo, I've taken a bunch of simple SQL queries. So let me just confirm that this is connecting to my read-write primary compute, which it does. And I want to run a simple query that shows me the top 50 records for the past 1 hour. So once I run this, it's a very simple query. It's taken a couple of seconds to run. And as you can see from the resource usage down over here, so that pretty much just took about 13% of the CPU. It didn't even utilize its full capacity. So, and bear in mind that this particular primary compute is also constantly ingesting data from the Stream Analytics output events. Now, while this is happening, I have a bunch of queries that I want to run on Hyperscale to do some reporting for my business, right? So using SSMS, I've connected to the read-only replica. Now, the way you connect to a read-only replica is basically going into your connection properties in your client tool and specifying an attribute called application intent equals read-only to ensure that it connects to your read-only replica. So let me just confirm that I've connected to my read-only replica. That confirms that. I can run a whole bunch of queries here, just selecting a random set of raw data queries. If I want to do a bunch of more CPU intensive operations, I can continue doing that. Even some really complex aggregations and some with some predicates and time conversions. So while this is running, you'd see that the CPU usage for my read replica would be going up. It wouldn't necessarily reflect in this, but if I go back to my primary compute and once again check the resource usage on my primary compute, if you notice the last was about 13%, it should still hang around that same percentage. In fact, it's lesser now, about 11%. So the CPU intensive queries that we are running at the moment are not necessarily impacting the primary compute because they're diverted towards the read-only replicas. So if I come here while this is still running, you'll notice that the CPU on this particular read replica would be shooting up while your primary would still remain the same. So this just gives you a sense of how you can divert your analytical queries to read replicas, and we allow you to scale up to 4 read replicas today, and we are planning to increase that limits to further in the roadmap. But that just gives you an idea of how you can constantly ingest data, whether it's IoT or real-time streaming devices, and still not be impacted from your reporting workloads. With that, I just thought I'll quickly show you what we have in terms of data generators. Now, it was obviously I couldn't bring IoT devices into this demo, so all I did was deploy a bunch of containers that basically run native code to generate data to about 10,000 messages per second. And that's pretty much what I did for this demo. So coming back to the presentation, let me switch my screen again. So that basically wraps up our discussion on hyperscale and managed instance. Now I'd like to pass this on to Ajay to then describe and discuss serverless as a service and a demo of serverless.
Thanks, Mohamed. So now that you saw Hyperscale is really designed to future-proof your growth of your compute or storage, serverless helps address a different category of problems. It basically helps with applications which do not need compute 24/7. It is used very good for intermittent applications which either run, let's say, very part-time, few hours a day or a few hours a week, month, year, etc. For example, applications such as sensors which only run at certain times, or if you have business apps, let's say like a weekend processing or end of quarter processing, or even applications like HR or performance reviews, which run only once or twice a year. So you don't want to pay for compute and just waste the resources. So this is where serverless helps with unpredictable workloads or usage patterns. The other scenario it helps is in DevOps scenarios. So here, Mohamed, if you click one more. Yeah. So if you're starting and building a new application and you don't know how much capacity you need, it's a great scenario to start with for serverless. And also, if you're in a dev test environment, you don't need the service of business hours. So here is also another good use case for serverless. Now, how does Azure SQL Serverless work? Let's look at some of the characteristics of the service itself. So as you can see, the first thing is it provides auto scaling. What I mean by that is you just have to specify a min and max compute, and the service will automatically scale up and scale down the compute based on the actual workload needs. And the second thing is when the service is not being used, you can configure what we call auto pause delay. And that means we will automatically pause the compute and release it and back up your database so you don't have to pay for the compute anymore. From a billing perspective, we provide the industry-leading granularity per second billing. So it's down to the 1 second of compute usage that you don't have to pay if you don't use it beyond the second that the last time you used. And you only get billed for the service. And since this is the same Azure SQL service like the other deployment choices, it's built on the same fully managed Azure PaaS platform. So you automatically get features like built-in HA, backups, automatic updates, running the greatest engine, etc. And overall, it gives you huge cost benefits, lowers your average utilization. As an example, if you see the chart on the right, your compute scales up and scales down between one CPU to 4 CPUs, the blue bar and the white bar. Even though you have configured the min and max at that numbers, the yellow bar indicates how much it's actually using, and that's what you get billed for. And then you have the pause section, which is your auto pause delay. So at that time, if your service is not being used, we will automatically remove the compute and back up your database, and you don't get billed for the compute. And then when the connection comes back in, we will automatically resume the compute and attach your databases. And from an application point of view, it's just a simple retry. So that's how serverless works at a high level. I can quickly show a demo of this in action. So let me go ahead and share my screen. Okay, so here I'm assuming you can see the screen.
Yeah.
Okay, so here the way to get started with serverless is very straightforward. It's just like creating any other Azure SQL database. So here in the portal, you can see that I have created a simple database here on my server. The only difference between a regular database and a serverless is this option here. If you select the left side, you get a regular database, which is the default, and it's provisioned compute, which means you pay for the service even if you're not using, and the billing is per hour. And you can see when I select that, if you look at the cost, estimated cost for that tier, it's $424 per month, right, for 2 vCores of compute. However, if instead, if I don't know how much I need, I can start with serverless, and you can see for a 4 vCore max that I picked here, my estimated cost lowers significantly down from $400 to $5. Like it's like almost 100x savings. And some of the other properties you can set, as I showed you earlier, you can set your min and max vCore, which is basically your scale factor between which the service will automatically scale up and scale down. In this case, you can go all the way up to 40 cores if you want more compute. And the last property that you can set is your auto pause delay. This basically tells the service how much of idle time that it needs to wait for before it removes the compute. So the lowest we offer today is 1 hour, which means if there's 1 hour of no activity, user queries coming in, then we will automatically pause the service. If you do not want auto pause, if you still want to leverage the scale capabilities, but you don't want to pause the service, you can uncheck this, which means the service will continuously run, but you still pay for the minimum bill if you're not using. In this case, you could still set it to the smallest compute, and then you only pay for, let's say I'm using 16 cores, and I can say my min is 2 cores. So which means if you uncheck this, you will only pay for 2 cores when you're not using the service. It's still cheaper than the provisioned option because we will scale it down. So these are the different ways you can set up the serverless environment. Now, I already have created a couple of databases. So let's look at a couple of other characteristics of the serverless. So here I have a PowerShell script. I'm going to go ahead and run this script to list all the databases in my service. And you can see here on the left side when this query finishes that I have one database, which S here indicates serverless. So I have one database which is online, couple of serverlet database have no activity running right now, so they are paused. And this is just your master database. And this is just the hyperscale database that Mohamed was showing. So that'll always be online because it's provisioned. So how do you resume a serverless database? It's pretty straightforward. So let's pick DB2, which is currently paused, to resume it. And I'm going to, so I have a retry script here. You can see all I have to do is initiate a connection string to that database. I have a connection timeout of 30 seconds, which is your typical application timeout that most applications set. And I'm having a stopwatch to see how long it takes to start the service, because there is no compute for a paused database, as I mentioned. It'll try to connect to it. If it does not successfully connect, I am going to catch the error and retry it. So this is best practice from an application design perspective. In general, even if you're not using serverless, so that you can trap intermittent errors like network glitches, etc. So you automatically connect, and that way your application users are graceful experience instead of having disconnects. So let's go ahead and see this, and let's see how long it takes for us to spin up a new compute, attach this paused database, and resume it. So let's go ahead and do that. So you can see at the bottom, currently the database is not active, so the connection state is closed. So the application is trying to connect to the database. What is happening in the back end is, as soon as the service gets the connection request, it knows that the database is paused. So now it's going to go spin up a new compute with the same settings that you had originally configured, because we saved those settings. Once the compute instance is ready, we will attach the DB2 database to that instance, right? So it can take a few seconds for this to run. So in order to save time, I will go back to the portal to show the next demo. So here in the here's a workload I had already done in the other database. So here's what I wanted to show you, the billing aspect of serverless. As you can see, I ran an intermittent workload which sleeps and wakes up and runs some queries and goes back to sleep. And if you look at my auto pause delay for this database, I've set it to 1 hour. So if there's 1 hour of no activity, it'll automatically pause the database. It's currently running a data workload, so it is currently online. But if you see the history here, I have 7 days of history I'm showing here. You can see that on the left side, I have a chart which shows compute utilization. On the right side, I see the bill. And as you can see, it shows synchronous scrolling. As I'm moving my mouse on the compute chart, you'll see the same bar on the aligned to the same time on the CPU chart. You can also see, pay attention to the these two numbers. You can see that when the compute is 0, you're not being billed for it. So the CPU utilization is 0. Now, when I put my mouse over the bar where the actual workload was running, now you can see that there is bill. So here there was usage. So you saw about 25% CPU, which means you're being billed per second for the vCore hours that were used. So this truly means that you're only paying for what you're using. So that's the billing aspect of serverless. So now let's go back to the service, and I will hand it back to Mohamed to continue with the next topic. Actually, I think I have to do it. So let's go back to the slide.
Yeah, I'm just resharing my screen, Ajay.
So you just saw a quick review of serverless and hyperscale. So now let's talk about what's new in Azure SQL. Being a cloud service, it's a continuous innovation. It's unlike a box product which you have to wait for every couple of years. Features in the cloud are continuously released across all our deployment options. For example, recently we announced change tracking for Hyperscale. You'll also see GeoDR capabilities where you can set up a DR instance in a different region and also copy databases to other instances that's coming for Hyperscale. On the serverless side, we recently increased the limit to 40 vCores, which you just saw now. We have the auto-pause delay for 1 hour. We're actually looking to reduce that as well as improve some connection resiliency. So the instance starts even faster than the 30 to 40 seconds it takes. And managed instance, this is something which we are continuously evolving for the last couple of years. All the information that you see here is based on customer feedback. We are improving the compatibility of managed instance with SQL Server on premises. So more and more workloads can move with least friction. We are continuously improving the networking and security footprint of managed instance so that customers can configure this easily without having to worry about opening up a lot of inbound, outbound traffics in their network. We're working to separate management traffic from data traffic and also bringing feature parity to managed instance, which the other flavors of Azure SQL already has, such as failover groups, accelerated database recovery, which are already there. We recently announced AAD authentication for password hash and password pass-through, and you will soon see point-in-time restore across subscriptions coming soon. So moving on to other deployment options, so that concludes the Azure updates. So if you want to keep up with more frequently, there's a link on the top of that slide, which you can subscribe to, which you will have as and when we have updates, you can see the announcements there, and we'll have link to blogs and documentation, which you can get more details. With that, I'll hand it back to Mohamed to talk about migration, because now that you heard about all the offerings, how do you get there from your on-premise workloads?
Thanks, Ajay. So one of the things that we have heavily invested and focused on is how do you move your on-premises databases or databases of different flavors and different cloud providers to Azure. And we want to make your journey as seamless as possible by providing tools that will help you migrate. So I'm going to spend the next 5 minutes just discussing some of these migration scenarios and tool sets, so you get a handle of how do you migrate your on-premise SQL Server, as an example, if you have legacy SQL servers in your organizations that need to be moved to Azure and so on. So the way we think about migrations primarily is dividing it into tool sets or terminologies around assessment and migration. Now, before we do migration, it's absolutely necessary to assess your database and data estate to figure out what level of capability, feature set, and compatibility you need when you move to Azure. To that extent, we provide first-party tools from Microsoft to help you ease that migration activity and the assessment activity. So when you talk about assessment specifically, we have a bunch of tools, namely Azure Migrate. Now, Azure Migrate is a tool set that provides or helps you with assessment of your entire data and server estate. I'll talk about that in further slides a little bit more. If you have databases like Oracle, which we consider as heterogeneous flavors of databases compared to SQL, we provide a tool called SSMA, which will help you assess your Oracle database for compatibility, for feature parity, if you want to move to SQL on Azure. Then we have Data Migration Assistant, which we refer to as DMA. And DMA basically does your assessments for SQL Server to, again, determine the compatibility and feature parity to move to Azure. Now, what we also support as part of migrations is not just Oracle and SQL, but we allow you to migrate your open source databases like MySQL and PostgreSQL to our equivalent in Azure, that's Azure Database for Postgres and Azure Database for MySQL. And if you have no SQL document databases like MongoDB, you can also migrate them to Cosmos DB in Azure, where we provide a MongoDB API for feature parity. Plus, we also allow you to bring databases from AWS and Google and other cloud providers into Azure. Now, once your assessment is done and you figured out that you've identified the target platform on Azure, we also have a first-party tool called Azure Database Migration Service, or DMS as it's called, to help you migrate those databases to Azure, both in an offline and an online mode. So if you have a requirement for extremely low downtimes and RTOs and RPOs, Azure Database Migration Service helps you migrate those databases to Azure with minimal impact to your business. Now, as I mentioned, those tools, now specifically for SQL Server, we focus on DMA and DMS. DMA is the tool of choice to do your database assessments. It's a very comprehensive tool which will give you a very comprehensive report on your feature parity, your behavioral breaking changes, and your compatibility levels. So you could take a SQL database from on-premises or another cloud provider or an IaaS workload, assess it extensively using DMA, produce a report, and then decide which database option would you want to move to Azure with. Plus, DMA also has capabilities to give you target and SKU recommendations. So if you're not sure where you want to go in Azure, it'll automatically tell you based on your workload on what the right fit would be in terms of Azure SQL. Now, once you've done the assessment, we also provide the service called Database Migration Service, which you can spin up using Azure Portal and which allows you to connect to your on-prem or source databases and provide a target environment where it can start migrating. And the migration can also happen online, as I mentioned. There's a high level of resiliency built in. So let's assume that something had gone wrong from an external networking point of view or whatever. During the migration process, we have resiliency built in to sort of restart from a point where you're having to do the migration all over again. So these two tools of choice for assessment and migration have been something that we've been providing to our customers to help migrate SQL servers to Azure SQL. Now, I spoke about Azure Migrate. Now, Azure Migrate is an interesting tool or a platform or a service rather, which allows you to not just migrate databases, but it provides a whole assessment migration experience for your entire data estate. This can involve not just your databases, but also your app servers or other servers that you might have in the mix in your data center. So Azure Migrate is at one single point of entry for you to go do comprehensive assessments of your data center. And it's primarily built for large-scale migrations. So for example, if you're looking at migrating hundreds of servers and you don't know where to quite start and what the discovery and assessment looks like, this is a perfect place for you to start, get a feel of what your estate looks like, what are the target options, how much effort is involved, because we also go down to the point of assessing your cost estimate for migrating those workloads to Azure. And it may also support, as I mentioned, migration from not just on-premises, but also from AWS and GCP. Plus, Azure Migrate has become this marketplace where third-party migration tools like Cloudamize and Unified Cloud provide their options to integrate with Azure Migrate, or their appliances to integrate with Azure Migrate. So it's become a hub for us to talk about large-scale migrations, both in terms of databases and servers. Now, keeping the tool sets aside, from a Microsoft standpoint, we are happy to help customers who are willing to migrate their data estate to Azure. And to that end, we have launched programs like Azure Migration Program, which helps you not just kickstart your migration, but support you all the way through that journey to skilling up your teams and your database administrators to keep up with how we do migrations and how we run things on Azure, to provide some fundamental formal training. We bring in specialized partners as part of this program to help you work with your engineers and your DBAs to migrate servers and databases. We provide a whole bunch of planning resources for you. And we also bring in the offers and incentives that are available at our disposal and your disposal to leverage for migrating your databases and servers. So Azure Migration Program is something that we work with customers on a nomination basis. So, if you're interested in having Microsoft support through that journey, feel free to reach out to Microsoft account teams or through to your right channels from Microsoft to nominate yourself so that we can get you plugged into the Azure Migration Program. Now, I just wanted to wrap this up by showcasing some use cases, and some of these are like fundamentally great use cases for us. The first one is Komatsu, which is local here in Australia. As you know, they manufacture and provide a bunch of heavy lifting machinery for construction and mining, etc. They had a requirement to scale up and ingest more data sets, and their on-premise systems were struggling to keep up with the increasing demand. So they decided to move to Azure SQL Managed Instance. They migrated the database estate. It was, when they started the migration, it was about 1.5 terabytes of data, and they're constantly growing. And they saw a reduction of about 49% in their costs and a price performance improvement of about 30% after migrating to Azure SQL Managed Instance, and they're consistently expanding on that journey. The next customer here is ClearSale. They're a company based out of Brazil. They provide software for e-commerce and online retailers to detect fraud in real time or in near real time as transactions happen. And again, their on-premise estate was finding it hard to keep up with the demand to produce near real-time fraudulent insights. And they decided to move to Hyperscale with the growing needs of storage and scalability. And as soon as they moved to Hyperscale, they were able to process pretty much infinite transactions per minute from various customers that they had to detect fraudulent transactions. And the last one is a customer called CampBrain in Canada, where they needed a system that could deal with high levels of unpredictability and spikes. As you know, camping is an activity in many parts of the world that's is very seasonal in nature, and they needed to keep up with spikes and demands at various points or various weather conditions. And for them, having a provision compute was essentially wasting their resources and money. So they moved to Azure SQL Database serverless, so that they could accommodate the spikes and keep up with the demands as and when they need, and automatically scale down to when they don't need the workload. So these are some of the use cases where we helped our customers use Azure SQL of various flavors. And we're constantly adding customers to this list. If you go to Microsoft customer case studies, you'll see a whole bunch of SQL customers where you can draw some references out of. With that, we've got about 7 minutes, so we'll wrap up with any questions or any discussions that you might want to have. Just going through the chat window here. I think we've answered some of those. John Zhang has a question on whether we can use T-SQL for Postgres in Azure Studio. I believe you can, John. I will paste a link to describe how you can use Azure Data Studio to connect to PostgreSQL.
If anyone else has any questions for Ajay and Mohamed, feel free to come off mute as well, and you're more than welcome to ask them using audio.
Well, I found the link if you want me to put it.
Okay, yeah, that'll be good. There was a question from Suraj. Suraj, happy for you to come off mute. Do we not need to take transaction SSL protection? I'm not sure if I understand that question. Suraj, if you're still online, happy to discuss that. I'm trying to infer
from a transport perspective, SSL encryption is automatically included. So we support TLS 1.2, which is the latest, and we'll add future versions too. So encryption in transit is fully covered automatically.
Hi guys, is there any concurrency limits on the hyperscale or the serverless model similar to what you have in Synapse? We have like different concurrency limits at different SKUs. So how is it managed?
No, it is not. So this is the same as SQL Server engine. So what the number of connections that SQL Server supports today depends on the tier you pick. And concurrency wise, you can go up to hundreds of queries. So it's basically number of threads. If you pick a very small compute instance, just like on premise, you may run out of worker threads, right? So that's the only way you can limit concurrency. Otherwise, by default, you can get high levels of concurrency.
Cool, thank you.
We can probably use this opportunity to even discuss any scenarios if anyone has used Azure SQL or if your organizations are using Azure SQL in certain ways. Happy to discuss that as well.
So I have a question about automatic tuning in Azure SQL database. So does that also provide index consolidation, or it just suggests like new indexes, and if it is not working, just delete that, then create a new one again, whatever is recommended?
So it does not provide index consolidation, but it tells you if there are unused indexes so that you can drop out. But if you have two indexes which cover same set of columns in different ways, unless one of them is not used heavily, it will not tell you that you need both.
Okay.
Benny, did you have a question?
Yeah, I was about to ask, like, is this under CI/CD at the moment? Like, can we deploy from DevOps?
Yes, so we do support DevOps for Azure SQL database, and I will share some links on that as well, where you can get started.
And can we switch between, say if you have a serverless on the dev environment, but just have a provisioned instance on a prod environment? Is it possible to do that?
Yeah, you can go back and forth between serverless and provisioned compute.
Thank you.
Because the database layer is the same for both. The only thing that changes is whether you want compute running 24/7 or on demand.
All right, if anyone else has got any last minute questions, feel free to jump in. We can probably do it for another minute or so. And then, because I just noticed we are at time for this session today.
All right, thanks, Nadia. Thanks for organizing this. And thanks, everyone, for joining.
No worries. Thank you so much,
Thank you,
Mohamed and
folks.
AJ.
Cheers. Thank you.
This has been great. Just to let everyone know, if you are interested in any of our upcoming events, check out our meetup page, which is meetup.com/Microsoft Reactive Sydney, to see all the other events we do have up and coming. I also have posted in the chat the Twitter and hashtags for Azure SQL as well, if you have missed out on that. Thank you everyone for joining. Thank you especially to Mohamed and AJ for that deep dive on Azure SQL. If you do have any questions, you can find me on LinkedIn or Twitter, and just feel free to reach out. Thank you everyone for your time, and we'll see you next time. Bye.
Bye.
See ya.
Thanks, guys.
Bye.